GitLab helps organizations achieve safe, low-risk, worry-free, and consistent releases. The best part? GitLab's platform makes the release process consistent and repeatable. Here's a release manager who's working on managing your release processes. But how? Incrementally, by adopting best practices and continuous delivery, or CD. Our release manager and her team remember the time when they worked all weekend to roll out an update to their messaging backbone, only to roll it back not long after. Back then, deployments and rollbacks were as complex as they were arduous. Processes were cumbersome and relied on multiple disjointed tools for a variety of process components, making progress tracking a nightmare. But it doesn't have to be that way. Let's see how GitLab and continuous delivery principles have helped your organization. A first incremental step towards adopting continuous delivery best practices works like this. Developers work on issues, stakeholders work on merge requests, or MRs, and at a predetermined point in time, the release manager declares a freeze and cuts the release. Enter GitLab, the one DevOps platform where all these activities are supported and actualized. Issues, where product problems or new features are described, and merge requests, where solutions are developed, are key inputs in the release planning process. They provide auditability and tracking of application changes, made in collaboration by DevOps engineers, system administrators, and developers. Here are some open issues and merge requests that are part of a specific project. Our release manager associates all issues with a milestone for the project's second candidate release, allowing her to streamline the milestone creation process. To track groups of issues that fall under the same theme, she creates two epics, one for the UI-related issues and one for the server-side issues. From here, she assigns all UI-related issues to the front-end work epic and all server-side issues to the back-end epic. These aren't all the agile methodologies available with GitLab. Next, she creates 2-week development sprints. First, she creates 2 consecutive iterations or sprints on the milestone timeline. Then, she assigns the corresponding issues to each of them. She can track the sprints through their detailed pages, which include various progress metrics. As she assembles the epics, milestones, and iterations, she's able to track the release visually via the roadmaps page, further streamlining the release process. She still needs to set a deploy freeze window. This halts automated deployments to production temporarily. The deployment freeze prevents unintended production releases for a period and reduces the risk of unscheduled outages. Additionally, as part of the approval gates, she can protect the production environment by specifying who is allowed to deploy to it. Role and responsibility assignments streamline the approval gates and release process. When the time is right, she creates the release, which automatically generates the release evidence. She then consolidates the release with the appropriate milestone. All of this works to streamline the process and reduces release cycle times. As a second step towards adopting continuous delivery best practices, changes are automatically deployed to the user acceptance testing environment, or staging, while deployment to production remains manual. Our release manager can cut a release from staging at any time, with no need for a deploy freeze. To speed up the process, she can take advantage of GitLab's auto DevOps capabilities, which help to create the release pipeline automatically. This removes the need to create a pipeline from scratch. As part of auto DevOps, our release manager can deploy to staging automatically, deploy to production manually, and enable canary deployments. The first job in auto DevOps is the build job, which applies the appropriate build strategy to create a Docker or container image and stores it in the built-in container registry. The auto build job uses a Docker file or cloud-native build packs to build applications into container images. Faster and more reliable releases happen when you have build components like container images that are readily available to the release process in a uniform and consistent manner. Our release manager verifies that the manifest digest of the container image, which is built by the pipeline, has indeed been stored in the built-in container registry. The auto build job could also leverage the built-in package registry to store and manage Maven artifacts so that Maven Central does not have to be scoured when building applications. Our release manager then heads over to the production environment to verify that the application has been successfully deployed and is running properly by logging onto it with a valid username. Notice that the color of the logout button does not match the background color, and there is also an outstanding issue with the merge request for it. As stakeholders make modifications to the application, our release manager has the ability to visualize what specific features will go into production via review apps. As updates are made to the application via merge requests, they kick off review apps, which streamline the review processing, including the automatic creation and destruction of an ephemeral review environment, on which stakeholders can verify the updates to the application before they are merged to the main branch. Review apps help increase code quality, reducing the risk of unexpected production outages. GitLab tracks every action taken to arrive at our release manager's desired outcome. In this instance, our color correction process is clearly defined, swiftly implemented, and easily audited. Once the application has been built and passed many automated tests, checks, and verifications, the Auto DevOps pipeline sets up a staging environment and deploys the application to it. At this point, our release manager can manually deploy the updated application as a canary deployment to the production environment. By doing this, she can ship features to only a portion of the pod's fleet and watch their behavior as a percentage of the user base visits the temporarily deployed feature. If all works well, she can deploy the feature to production, knowing that it won't cause any problems. She can then proceed to start rolling out the canary deployment to 100% of the production pods. Incremental rollouts lower the risk of production outages, delivering a better user experience and customer satisfaction. Advanced deployment techniques like canary, incremental, and blue-green also improve development and delivery efficiency, streamlining the release process. To check the running application for integrity, our release manager clicks on the Open Live Environment button. She notices that the attempt to log into the application fails and decides to perform a rollback. She drills down into the production environment page and identifies the release that had been successfully running before the last deployment was performed. This page is an auditable sequence of changes that have been applied to the production environment. She clicks on the rollback button to start the rollback process. Rollbacks speed up recovery of production in case of failures, lowering outage times and leading to better customer satisfaction and user experience. Pipelines usually run automatically. However, to have the most recent staging version of the application on a daily basis, it is best to schedule the execution of the pipeline once a day at midnight. To do this, our release manager goes to CI/CD schedules and creates a new schedule. Scheduling pipelines can improve the efficiency of the development lifecycle and release processes. While the application is running in production, she would like to understand how the release is performing and quickly identify and troubleshoot any production issues. There are a few ways she can do this. One way is to access the monitoring feature for specific environments to track system and application metrics, such as system and pod member usage and number of cores used. Monitoring tracking includes markers, the small rocket icon, which identify when updates are introduced to the environment. This way, fluctuations in the metrics can be correlated to specific updates. Monitoring reduces the time to identify, resolve, and preempt production problems, lowering the risk of unscheduled outages. It also provides an opportunity to do business activity monitoring and optimize cloud costs. Not only is this type of monitoring useful to release managers, but also to DevOps engineers, application operators, and platform engineers. For manually configured Prometheus servers, our release manager could monitor the release by creating alerts to detect out-of-range metrics, which would be visible on the overall operations metrics dashboard, as well as on each specific environment window. Alerts can also automatically trigger the creation of incidents, chat ops, and email messages to appropriate individuals or groups. She can manage alerts from the Operations Alerts window, a single location from which she can assess and handle alerts, which may include the manual or automatic rollback of a release. In addition, she can track and monitor the release progress through Value Stream Analytics. Our release manager can check project or group statistics over time, see how the team improves in lead time, cycle time, lead time for changes, number of new issues, commits, deploys, and deployment frequency. She can also check the median time spent in each phase defined in the process, such as issues, plan, code, test, review, and staging. Value Stream Analytics are useful to quickly determine the velocity of a given project or group. They point to bottlenecks in the development process, enabling management to uncover, triage, and identify the root cause of the slowdowns in the software development lifecycle. She can also track and monitor releases via Pipeline Analytics. Pipeline Analytics show the history of pipeline successes and failures, as well as how long each pipeline ran, helping her understand the health of projects and their continuous delivery. Pipeline Analytics also report on DORA 4 key metrics, which are performance metrics that measure the effectiveness of an organization's development and delivery practices. Deployment frequency measures how often your organization deploys code to production or releases it to end users. Lead time for changes measures how long it takes to go from code committed to code successfully running in production. Time to restore service is the median time an incident was open in a production environment in a selected time range. And change failure rate is the number of incidents divided by the number of deployments to a production environment in a selected time range. Like Value Stream Analytics, Pipeline Analytics help identify bottlenecks in the development process, enabling management to uncover, triage, and identify the root cause of slowdowns in the software development lifecycle. Our release manager oversees more than one release, so she updates her operations dashboard by adding this project to it. Through this dashboard, she gets a summary of each project's operational health, including pipeline and alert status. Similar to the operations dashboard, she can also access the environments dashboard, which provides a cross-project environment-based view that lets her see the big picture of what is going on in each environment. Or she can drill down into a specific environment to get all the updates that have been applied to it. These dashboards provide her with the operations insight she needs to understand how the release is performing in production and quickly identify and troubleshoot any production issues. As a third incremental step into adopting continuous delivery principles and practices, all changes go to production. This is also known as continuous deployment. Modifications to the application are immediately rolled out to production after passing many checks and verifications via the CD pipeline. Our release manager can enable this by setting the continuous deployment option for the Auto DevOps deployment strategy. Here, we can see how she utilizes GitLab's sophisticated integrated deployment function. In doing so, she is able to monitor the pipeline as changes are deployed directly to production. She would like to exercise a feature flag. This segments the audience who will be exposed to new features in specific environments. She opens up the feature flag window and checks the feature flag Products in Alphabetical Order feature flag, which has 3 strategies, and a user list called Product in Alphabetical Order User List, with 2 users in it, Michael at cfl.rr.com and Mary at cfl.rr.com. The first strategy uses a percent rollout of 50% based on available ID for the production environment. The second one targets the feature to users in the user list, Products in Alphabetical Order User List, for the staging environment. The third strategy serves the feature to a specific user, Henry at gmail.com, for the review environment, which is an ephemeral environment used for validating application updates before they are merged to the main branch. feature flags help our release manager reduce risk, allowing her to do controlled testing and separate feature delivery from customer launch. She would like to verify the feature flag strategy in action in the staging environment. She opens the application in the staging environment and logs in as a valid user. She validates that the user gets a product list sorted in alphabetical order by product name. She logs the user out. This time, she logs in as a second valid user. She confirms that the second user also gets the feature in the staging environment. Remember that the first user and the second user were part of the user list allowed to see this feature in staging. Finally, she logs the second user out, and, still in staging, our release manager logs in as a third user who should not be served this feature. Indeed, this third user does not get a product list in alphabetical order. She checks the feature flag strategies again and notices that the strategy for the review environment has a bad email address. She would like to identify who was the last person to modify this strategy feature flag and open the project's audit events dashboard. She notices that a developer in the organization is the person that they need to communicate about the bad email address to. Our release manager also checks security and compliance-related items of the project by going to the security dashboard. She sees that there are 8 critical vulnerabilities to follow up on. These dashboards help her preempt out-of-compliance scenarios to avoid penalties. These dashboards also streamline audits, provide an opportunity to optimize cost, and lower risk of unscheduled production outages. Whether you're in the middle of your DevOps journey or just starting, GitLab helps at every step.